All right, let's talk about one of Python's most powerful and maybe sometimes confusing features, decorators. They can feel a bit like magic, but I promise, by the end of this, you'll see exactly how the trick is done. More than that, you'll be ready to build your own and write some seriously clean, powerful code. So let's just dive right in. I'm sure you've seen this little guy, the @ symbol, all over the place, right? Especially if you've ever touched a web framework like Flask or Django. Well, it's not just some weird decoration. It's a massive clue that something really cool is happening. It's a way to supercharge a function, to give it new powers, without ever changing its original code. And we're about to break down exactly how it works. So this really gets us to the core problem that decorators solve. Imagine you have, say, a dozen functions, and you need to add logging to all of them. Or maybe you need to time how long they take to run. Are you going to go and copy-paste that same chunk of code into every single one? No way! That's a maintenance nightmare waiting to happen. There is a much, much better way, a much more Pythonic way. To get to that better way, we first need to open up our toolbox. See, Python has a few fundamental concepts that all come together to make decorators possible. Once you get these down, that magic we were talking about, well, it's going to make perfect sense. First up, higher order functions. Now, this sounds a little academic, but the idea is simple and it's absolutely crucial. In Python, functions are what we call first-class citizens. That just means you can treat them like any other variable. You can pass them into other functions, return them from functions. You can handle them just like you would a number or a string. This single idea is the bedrock of decorator. And here's the thing. It's actually super simple in practice. Look at this. You can have a function that literally takes another function as an argument and then just calls it. This ability to treat code as data is what gives Python so much of its incredible flexibility. Okay, tool number 2 in our toolbox, nested functions. You can literally define a function inside another function. And this is awesome for organization. You can create these little helper functions that only exist where they're needed, and they don't clutter up the rest of your program. Plus, that inner function can see and use all the variables from its parent function. Think about it, right? Maybe you have a small helper that only makes sense within the context of its parent function. By nesting it, you keep your main program tidy, you avoid polluting your global namespace with functions that have a really specific, limited job. It's just good, clean coding. And here it is, the final piece of our puzzle. Functions can return other functions. But here's the secret sauce. When that nested function gets returned, it doesn't get amnesia. It remembers where it came from. It carries its parent's variables and environment along with it. This concept is the key to how decorators actually work. All right, so let's recap. We know that functions can take other functions as arguments, they can have functions nested inside them, and they can return those nested functions. We have all the building blocks. Now, let's put them together and build our very first decorator. This is where it's all going to click. It's really just a simple 4-step recipe. First, you define the outer function. That's the decorator itself. Second, inside it, you define a nested wrapper function. Third, inside that wrapper, you put your new logic, maybe a print statement before and after, and you make sure to call the original function. And fourth, the outer function returns the wrapper. That's it. And here's what that recipe looks like as actual code. Now, after we've built our decorator, we could do this manually. We could write say hello equals my decorator say hello. That works, but Python gives us this beautiful, clean @ symbol. It's what we call syntactic sugar. It does the exact same thing, but it's so much more readable. Okay, so you're probably thinking, wait a second, my functions almost always have arguments, and they usually return something. Our simple example doesn't handle that. So how do we make a decorator that can work with any function? Well, the answer is a little bit of Python magic called star args and double star kwargs. These are amazing. Inside our wrapper, star args will scoop up any positional arguments into a tuple, and double star kwargs will grab any keyword arguments and stick them in a dictionary. Then we can just pass them straight through to the original function. We also make sure to capture the original function's return value and return it ourselves. And boom, just like that, our decorator is totally generic and reusable. So far, we've been deep in the weeds of Python code and syntax. But what we've actually been doing is implementing a classic, time-tested idea from computer science known as the decorator design pattern. So let's zoom out for a minute and look at the blueprint behind the tool we've been building. So it's really important to separate the idea from the implementation. The decorator pattern is the general blueprint. It's a strategy for adding new features to an object without changing its structure. Then you have Python's decorator, the syntax, which is the specific, elegant tool that Python gives us to apply this pattern directly to functions. And this quote right here, it hits the nail on the head. The key word, the most important verb, is wrap. You take your core object and you wrap it in another object. That new object adds some extra behavior, and then it delegates the main job back to the original object it's wrapping. You know what? Let's make this way less abstract. Let's talk about coffee. Our base object is just a plain black coffee. It's simple. It has one job. Tell us its cost. Okay, but what if a customer wants milk? Instead of messing with our original coffee class, we create a milk decorator. This decorator wraps the coffee object, so when we ask for the cost, the milk decorator first asks the original coffee for its cost, and then it just adds the price of milk on top. And this is where it gets really powerful. Because our milk decorator still acts like a coffee object, we can wrap it again. We can take a sugar decorator and wrap our milky coffee. It'll just add its cost to the total. We can keep stacking these wrappers, these decorators, as high as we want. This entire approach is a perfect example of a fundamental role in good software design called the open-closed principle. It means our system is open for extension. We can add a caramel decorator, a whipped cream decorator, whatever we want, but it's closed for modification because we never, ever have to go back and change that original stable coffee class. All right, theory's great, coffee's delicious, but where does this stuff actually show up in real-world code? Let's take a look at some examples you've probably already seen, which will prove just how essential this whole idea really is. I bet you've already used decorators without even realizing it. In Flask, @app.route is a decorator that transforms a normal Python function into a web page handler. In Django, @loginRequired wraps a view to check if a user is logged in first. Even standard Python features like @property or @staticMethod are decorators. And my personal favorite, @LRU cache from functools, which can magically make your functions faster by caching their results. So what's the big takeaway here? Why does this all matter? It's because decorators let you separate your concerns. Your main function can focus on doing one thing well, its core business logic. And all that other stuff, the logging, the caching, the permission checks, that can be handled by clean, reusable decorators. It just leads to code that's so much easier to read, to test, and to maintain. So now you know. You've seen behind the curtain. You have the blueprint, you have the tools, and you understand the why behind that little symbol. The question isn't what decorators are anymore. The real question is, what amazing, clean, and powerful code are you going to build with them?